Today, Section 2.4. Section 2.4, we're going to have lots of exciting kind of problems. What kind of problems are we going to have? Word problems, the favorite kind of problems. Word problems. All right, so let's just do some word problems here. The average attendance at University of Southern California home football games increased approximately linear from 59.0 thousand in 2001 to 91.4 thousand in 2006. Determine the average rate of change, which is another way of saying slope, and we'll talk about why that is in just a minute here, per year of attendance. Okay, so how are you going to find the slope? All right, to find the slope, we're going to use our favorite slope formula. M is y2 minus y1 over x2 minus x1. So what we need to figure out here, we have a couple different kinds of data. We need to figure out which one is x and which one is y. So the different types of data I see 59,000 in 2001. So I see number of people, and I see a year. And then here, again, I see a number of people, 91.4 thousand, and then again, I see a year. Which variable do we want to be x, and which variable do we want to be y? Years to be x. How come? It's one we know. Time is almost always x. All right, so what they've really given us is, they've given us 2 points. So how do I want to write my first point? What's my x number for my first point? Well, for the first point, what's the x number? It could be 2006 or it could be 2001, whichever one you want to write down first. It doesn't really matter. But we decided time should be our x. So I think I would put 2001, since that's what came first. And my y value there would be 59. And then my next x value was 2006. And my y value would be 91.4. All right, well, we still haven't answered the problem. Now what do we need to do? Now we need to find the slope. All right, so our slope is going to be y2 minus y1. That's 91.4 minus 59 divided by 2006 minus 2001. I grab my calculator. 91.4 minus 59. Oops. 91.4 minus 59 divided by 2006 minus 2001. I can do that in my head. How many years is that? 5. That's 5 years. So our slope would be 6.48. So there's the number. The slope is just a number. Slope is 6.48. Now here comes the important thing, really. Part B. Explain the meaning of the slope in the context of this problem. What do I mean by that? Okay, so I want you to tell me something about average rate of change in terms of attendance in years. So what a lot of people will say here is the slope is positive, the line is going up. Is that true? Yes, true, but it's not really the answer I want. What does this number, 6.48, have to do with people attending the football games? It's how much more is going up each year. So what this number 6.48 means is attendance increases by 6.48 per year. 6.48, I missed a word there, thousand per year. When I say explain the meaning of the slope, that's the kind of answer I'm looking for. Your answer should have something to do with attendance in years. And if you don't have those words written in there, then you probably don't have the right answer. Okay, questions on that? So that's called the average rate of change. The average rate of change is how much something is changing per year or per month or per day, depending on what kind of units you're using in your problem. In this case, it's per year. So the slope is always going to be another word for average rate of change. So anytime you see the words average rate of change, you know right away you need to find the slope. So I won't always put slope like that in parentheses. From now on, you should just know that. Average rate of change is just another word for slope. All right. Determine a linear equation that models the given data. Okay, so we started with 2 points. From our 2 points, we found our slope. That was good. Now you need to find the equation. How do you find the equation if you know the 2 points and you know the slope? You have 2 choices. You can use y equals mx plus b. Close. It's the other way around. Y minus y1 equals m times x minus x1. Which one do we want to know? Which one do we want to use, I mean? The second one. Why do you prefer the second one? We do not have the y-intercept. How do you know you do not have the y-intercept? Because we would have to have 0 comma something to have the y-intercept. We don't have the y-intercept. So since we don't have the y-intercept, again, either formula will work. My preference would be to use this one. Y minus y1 is m times x minus x1. So I would write it as y minus, I'm going to use that one, I guess, 59 equals m, 6.48, times x minus 2001. I'm going to go ahead and clean that up. I think I'm going to write y minus 59 equals 6.48x minus, and I'm going to distribute that 6.48 through, so 2001 times 6.48 is 12966.48. I want to get the y all by itself, so to get the y all by itself, what do I need to do? Add 59 over there. So y equals 6.48x minus, I got the wrong number here. Put the wrong number. Minus 1.12966.48 plus 59. I'm having calculator issues today. I get minus 12907.49. Agreed? You got 48. Yeah, 48. What don't you get what I did? One that carried over to the 12.
Oh, no, sorry.
Okay, so what I did, here I just plugged in numbers. Y1 was 59 from back up here. Slope was 6.48 from there. And then X was 2001, so I just plugged in my numbers. Then, for this next line, I just took the 6.48 and I distributed it through. So I took the 6.48 and multiplied by X, and the 6.48 and multiplied by negative 2001, and that's what I got. And then finally, to get the y all by itself, I just added 59 to both sides. That's what I ended up with. Part D, determine the y-intercept of this model. Well, that should be pretty easy. Now that we have y all by itself, that's why I really wanted to get y all by itself. I was looking ahead at the next question. What's the y-intercept? 0, comma, negative 12907.48. Explain the meaning of the y-intercept in the context of this problem. What does it mean to have 0 right there for x? In year 0, in theory the year that Christ was born, how many people attended USC home football games. Negative 12,907 of them. 0.48 thousand even. Yeah. So, what the heck does that mean? It really doesn't have meaning, does it? What's happening? Our data was 2001 and 2006. Does it make any sense at all to try to go back 2001 years and predict what happened 2001 years ago? No. So in this situation, explain the meaning of the y-intercept. My answer would be, it has none. It's way too far outside of the data set to make any meaning at all. Yes, we cannot have negative people. Certainly cannot have negative people attending a football game. So we had a fancy word for that a few sections ago. Anybody remember the fancy word that we had for the answer we get doesn't make any sense? Not undefined. Model something. Model breakdown was the fancy words we had. So that would be a good answer right there. A good answer right there would be model breakdown. Doesn't have any meaning to us. Way too far out of the data set. Part F. Use the model to estimate the attendance at football games this year. So this year is 2013. Do I plug that in for X or do I plug that in for Y? Why do you plug that in for X? Because X is the time. So this problem, they're asking me X is 2013. So Y would be 6.48 times 2013 minus 12907.48. I grab my calculator. 6.48 times 2013 minus 12907.48. My calculator says Y would be about 136.76 thousand. Questions on that? Don't flip the page yet. I like that problem so much I'm going to do it again. I need a clean one. So you don't have to write the whole thing down again. I just want you to show you a slightly different way to do it and why I would do it this way. What we did there, by the way, that's 100% perfectly correct. If this were a problem on a quiz or a test, and that was the answer you gave me, completely correct. Very happy with that answer. But I've got a better way. Here's what I'm going to do this time. This time, when I create my two data points, I'm going to do this. I'm going to say, instead of calling this 2001, I'm going to say, let's consider that we are starting in 2001. So I'm going to call this year 0. And so if this is year 0, what's my Y number? My Y number is still 59. But now if I'm calling 2001 year 0, what's my X number for the next point? Not 6, it would be 5, because from 2001 to 2006 is 5 years. So this would be 5, 91.4. There's a big advantage to doing it that way, and we'll see why in just a minute here. Does it change anything when finding my slope? Well, let's just try it. M would be 91.4 minus 59 over 5 minus 0. Work that out. I think you'll find you still get 6.48. I don't think that changes at all. That was a number we had before, right? Yeah, 6.48. Number mean? What does slope mean? Same thing it meant before. Attendance goes up by 6.48 thousand per year. Okay, so not much has changed yet, has it? Here comes the big one right here. Determine an equation that models the given data. Here's the big advantage. Do I know the slope? Yes, the slope is 6.48. Do I know the y-intercept? Yes, the y-intercept is 59. So that's a much nicer way to write your data. It makes some work easier in the future. This time, if I find my equation of my line, I'm going to use y equals mx plus b. I would have y equals 6.48x plus 59.
How come 59 is one?
How come 59 is the y number? Or how come it's the y-intercept?
I'm just confused on why you chose 59.
I didn't choose 59. 59 was given to me in the...
Yeah, I know that, but I don't get it.
How is it that the 59 is the one that's there, but when we figure it out, it's different?
Okay.
That's because it's the years.
Because of the way we wrote our data. Here, we wrote our data, we decided in this problem to use the specific year. We decided to write 2001 there and 2006 there, which is fine. There's nothing wrong with that. Okay? But now, if I ask you, do you know the y-intercept, the answer is no. To know the y-intercept, you have to have a 0 in one of the x positions. And we don't have that. If you're a little bit more clever, I think you write your data this way, where you say, I'm going to call 2001 when I started. So I'm going to call that year 0. So if I start in 2001, if 2001 is year 0, that means that 2006 is 5 years later. So that has to be the number 5 there. This is a more clever way to set up your data. And the reason it's more clever is when you get to this point, you know the y-intercept right away. And it makes it much easier to find your equation. And the number is a heck of a lot smaller. I'd much rather write 59 than that negative 12,000 something, something, something that we had before. I didn't like that number very much. I agree. Okay? So, this is a nice trick here. Whatever your data is given, whatever your first x number is, call it 0. And then whatever your next x number is, just call that however many have gone since then. And that way you'll always know the y-intercept. So, determine the y-intercept. The y-intercept is 0, 59. So part E now changes dramatically. Explain the meaning of the y-intercept in the context of this problem. What does the y-intercept mean now? Now it's not model breakdown anymore.
Where is it, where we started tracking?
In year 0, when we started tracking, population was 59,000. So I would write in 2001, attendance was 59,000. So notice that that's kind of interesting, that depending on how you do the problem, you get two very dramatically different answers for that question. The first time we did it, we said it was model breakdown. It didn't make any sense, which was correct for the way we did it. If you do it this way, if you were to tell me model breakdown, I would have to mark that wrong because it's not model breakdown. That's a definite meaning this time. All right, slight change in part F also. Use the model to estimate the attendance in football games this year. What number are we going to plug in for X? And the big mistake people will make is they will plug in 2013 right here. I heard somebody say that and then they changed their mind real quickly. You don't plug in 2013 because now X means how many years since 2001. So how many years have gone by since 2001? 12. So again, that's slightly different. You plug in X equals 12 this time. So you would have Y equals 6.48 times 12 plus 59. And I hope we still get 136.76. We should still get the exact same answer, even though we set our data up differently. Let's see, 6.48 times 12 plus 59. I get 136.4. 136.76. I get a different answer. Oh, because I typed it into my calculator wrong. How's that for a good answer? 136.76. Type it into your calculator correctly, you get the right answer. That's nice. I typed it in wrong the first time. All right, so there's a nice little trick. This is the way I almost always do things. I always call my first data point 0, comma something. And then I just force my next data point to be based on that. And that way I always know my y-intercept. It makes it easier. All right, now let's try number 2. Retail sales of men's skincare products were 68.9 million in 2006 and have increased by 4.66 million per year. Let S be the retail sales in millions, that is T years since 2006. That problem sounds familiar. Anybody seen that problem before? Yes? Where have you seen that one before? That was on the packet on Monday. That's correct. Exact same wording. Now I'm going to ask some different questions, though. Part A. Determine the average rate of change, also known as the slope, per year of the sales. I gave you the slope. What's the slope? 4.66 million per year. How do you know that's the slope? It says there's 2 big hints. One, it says the word increased. Slope tells you increasing or decreasing. And the other big hint is it had the word per. Anytime you see the word per, that's going to be your slope. So our slope is just a number. Our slope would be just 4.66. Meaning of the slope in the context of this problem. Sales increase by, it says that right in the problem, doesn't it? So that one's pretty easy. Sales increase by 4.66 million per year. I'll almost copy the wording right out of the original statement there. Determine a linear equation that models this data. All right, so again, we need to make a decision. Do we want to use y equals mx plus b, or do we want to use y minus y1 equals m times x minus x1? Okay, so y equals mx plus b. Except, I really shouldn't use y and x. How come I really shouldn't use y and x? Because the problem says I should be using s and t. So I should really have s equals mt plus b. So S is, what's M? 4.66 T plus, well, what's B? 68.9. All right, so Y is B 68.9? Because we're starting in 2006. So we're doing the same sort of trick. We're calling 2006 year number 0. So in year 0, we had sales of 68.9 million. So it's really the same trick. Think of 2006 as year 0. All right, D, what's the y-intercept? 0, 68.9. That's what we just decided we were going to do. We decided we were going to call year 2006 year 0. Explain the meaning of the y-intercept in the context of this problem. What does 0 mean? In the context of this problem, what does the 0 mean? 0 is year 0, which is 2006. So in 2006, sales were 68.9 million. So again, you almost copy that right out of the wording given in the original problem. And then part F, use the model to estimate sales this year. Well, what year is this? This is 2013, but again, we started in 2006, so T would be 7. 7 years have gone by. And again, the big trap people will make right there, they'll plug in 2013. Watch for that. T is 7. So S is 4.66 times 7 plus 68.9. Grab my calculator. Hopefully I can type it in correctly this time. I get 101.52, and the units would be millions of dollars. Questions on that? Problem 3. That's one for you to try. You've got, we've got 15 minutes left. Give it a try. I'll walk around and see how you're doing. So, what's the slope? Negative 0.05. How did you know it should be, how did you know the number 0.05 was involved with the slope? It said per. And then why did you decide it should be negative? Because when you drive around, you burn gas. Your gas is decreasing. So slope has to be negative. And that's a simple one people will miss there. Explain the meaning of the slope. You're using 0.05 gallons per mile. That's exactly correct. The car burns 0.05 miles per gallon. Determine an equation for G. G of x is? All right, so why did you decide the y-intercept was 15.3? Because that's how much gas you can have. So when you've driven nowhere, when you've driven 0 miles, how much gas do you have? Well, it said you just filled up your tanks. You have a full tank. So our y-intercept is when we've driven nowhere, we have 15.3 gallons. Explain the meaning. I just did, didn't I? When we haven't driven anywhere, we have 15.3 gallons of gas. At the start, we have 15.3 gallons. Determine the x-intercept. How do you find the x-intercept? Plug in 0 for y. In this case, y, we're using the symbol g of x. So 0 equals minus 0.5x plus 15.3. Subtract the 15.3 on both sides. Minus 15.3 equals minus 0.05x. Divide by minus 0.05. And x was, I forget what you get, 306. So what does that mean? It means 306 is, that's how many miles you can go. So when you've driven 306 miles, what's going to happen? You have no gas. So that's the very next question. Explain the meaning of that. When you drive 306 miles, after 306 miles, no gas left. You used it all up. All right, and then this is something we haven't done in a while. So this was nice to throw this back in. Domain and range. What does domain mean again? The x numbers. So what are your possible x values? Well, you could choose not to drive anywhere at all. And then what's the furthest you can drive? 306 without filling up your gas tank again. So there's your domain. You could go nowhere, or you could go up to 306 miles. And what's your range? Well, you could completely empty your gas tank, which means you would have no gas left. Or what's the most gas you can have? 15.3. So there's your range. Questions on that problem?
Now, when you say, what's the slope in the context, I have to put in the number and I just go and use that to
No, I want more specific than that. You're correct. If you say the slope means I'm burning gas, that's correct, but I want it more specific than that. I want to know how much gas you're burning. Okay, so I should see that number there somewhere in your answer. The car burns 0.05 gallons per mile. Questions on anything? See you Friday.